Next greater element of some element x in an array is the first greater element that is to the right of x in the same array. Is the first greater element that is to the right of some element, the next greater element of some element x in an array is the first greater element that is to the right in x, well, of x in the same array. Okay, that makes sense. So 1 doesn't have a next greater element because nothing to the right of it is greater. 3 is immediately greater. So yeah. Okay, you're given two distinct zero-indexed integer arrays, nums1 and nums2, where nums1 is a subset of nums2. For each, yeah, you know, I feel like that makes sense. Okay, find the index such that nums1, what? Is a subset of nums2 for each, okay, find the index j such that nums1 I equals nums2 j, and determine the next greater element of nums2 j in nums2. Okay, so nums1 is a subset of nums2, and we're saying, I'm confused. Okay, find the index j such that nums1 I equals nums2 j, and determine the next greater element of nums2 j for each value in nums1. Find the index j such that, okay, so find its matching. Yeah, the language is annoying. Find its match in nums2 because you know it's gonna be in nums2. Are there any repeats? Are they all distinct numbers? Yes, they're unique. Okay. Could you find an O nums1 length and no nums2 length? So that's I feel like it's just a long walk for a short drink of water, essentially. Um because first we need to find the, okay, so we're, is the next greater element. So this one doesn't have a next greater element, so it's -1. 1, the next greater element is 3. Okay. So the the brute force solution would be to take nums1 and say, okay, so iterate through until we get the matching number, and then from that point iterate through until we get a greater number, and then set that to be the number. So maybe we'll do something like ants equals 0 for blank in nums1. I always like to do that to establish the array and then just change the values instead of changing the length of the array, because that mucks with the pointers and stuff. Okay, so what? So the intuitive solution would be to just say um, for let's see, for I in nums1. So we're going through all the numbers in nums1. Then we're going to say for j in nums2. We know that the nums have to be less than or equal to 2, so it's okay that the answer starts with 0 because they can never be 0. So, yeah. So we're going to say for j in nums 2, sorry, for I in range, length of nums 1, range, length of nums 2. Okay. We're going to say if nums, actually we could just hold on to that number. We're going to say num1 equals nums1 I. If num1 equals nums2 j, then we're going to try to, let's see, if num1 equals nums2j, then we're going to just keep iterating through j. How about we have something like a Boolean that we flip? And then from there, if that Boolean's true, we're going to say found number equals true. All right, and now once we found the Boolean, if nums2, let's see, we'll say num2 equals nums2j. If num2 is greater than num1 and found number, so we've already found the number and now we're looking to the right of that number, then we say actually we could also just set these all to be -1 because if they're never set, then we don't even need to update them. Then we could say ants I equals num2. That actually should do it. We don't even need to check any other conditions because we're not, if we never actually, if there's no next greater number, then we just never update nums1. So return answer. Wrong answer. Uh-oh. I'm confused. Um, Found number equals false. Oh wait, it's because we're updating the value. We need to break it. Oh, sorry. No, we need to break it when we update the value, not when we found the number. Break. That does it. Bam. And it's slow. How do I make this faster? Do we use one of those dang hash maps or something? Do we get the indices of I think that one thing is that one way that we're wasting time is because we're going through the array all over again. When we could do one pass through and match up those um, indices. So here's what we'll do. We'll keep answer the same, but we're gonna rewrite the entire thing. The first loop is going to be go through nums1 and find all nums2 locations. Okay, we'll put that in, I don't know, a map. I mean, we don't even need a map. We could just use an array. They should be the same. It's at the end of the day, you're still just associating the index with the Okay, we'll just do an array. Nums. Okay, well, we're gonna say nums2 locations equals nums2 locations. Okay, so now we're going to go through nums2 locations and we'll just start, I don't know, why don't we just start out nums2 locations? All right, so now we're going to use this array is going to hold on to the locations of all the values in nums2. So how do we find those? Oh wait, we'll do this. We'll say we'll make that be a dictionary, and that dictionary will hold on to all the values in nums1 and their associated location. Okay, so we're going to say nums2 locations is a dictionary, and we're going to say for I in range length of nums1. So we're going to go through all the values in nums1, and we're going to try to find their location in nums2. Could we use index of? No, the goal of this is to basically avoid doing a pass-through of nums2 every time that we want to do a pass-through of nums1. So maybe we'll just say for num in nums1, we're going to say nums2 locations, and we're going to set those all to just be -1. Num equals -1. Okay? Because you can't have -1 for a location. Well, I mean, you can, but you know what I mean. For in this case, it's not going to matter. Okay, for num in nums1, can we do none? Yeah. Okay, so we're going to say for now that we have this, now we need to go through nums2. Maybe, let's see. So we have all those locations, and what we're going to try to do now is actually write them. Because we just have the keys, and now we're going to say for num in nums2. Actually, we're going to say for j in range length nums2 because we want the index, not the. No, wait. Yeah, okay, yeah, we want the index, not the value itself. We're going to say if num equals nums to j, if num in nums2 locations is that, I mean, is that just, is this costing all the time? If num in nums2 locations, then nums 2 locations num equals j. All right. That's all we need to do. So now we have a dictionary that contains locations of num1 values in nums2. So now we could say now we're going to say for num in nums1, we're going to go through that array again. And we're going to say actually we want the index again. We want the index range length of nums1, and we're going to say we're going to get the starting index. That's going to be nums2 location. We're going to say num equals nums1 I. Starting index is nums2 locations num. Okay, plus 1. And now we're going to say for, well, it's like a sort of shrunk down nested loop. For j in range starting index up to the length of nums2. So cool. Starting index up till length of nums2. We're going to say if num is less than nums2 j, break. And before we do that, we need to actually set the value. We're going to say answer I equals does that work? What? No. No. That's gotta be a glitch. I can't have 2 in a row. What happens if I run it again? What? No. Something's gotta be glitched out here. How is that so fast? I don't get it. I don't know, but I'll take it.